Let's look at a little more detail about what happens when you try to create an instance of a class that you defined. Object construction implements this idea that all bank accounts should have a balance and an account holder. It's got to be up to the account class to add those attributes. And what happens when you define and then call a class is that a new instance of that class is created, and it knows it's an account, but it's a blank slate in terms of attributes. Those need to be added using an init method. And the init method of a class is called with the new object as its first argument, which we always name self, along with any additional arguments provided in the call expression. For example, Alan here is provided as the account holder. So here's the definition from the class that we showed earlier. And what happens is that first an instance is created that doesn't have any attributes, and then init is called on this new account instance and Alan. The account instance is empty for now, but as soon as I start assigning attributes, since self refers to the account instance, self.balance equals 0, we'll add a balance attribute bound to 0 to the instance, at which point we could later look it up. Likewise, self.holder will add a holder attribute. And now this instance has two attributes. It's ready to be used like an account. The init method is sometimes called a constructor method, and that vocabulary is used in other programming languages as well. This one call expression does all that work, 1 and 2, at which point we can now refer to the attributes of A. An object's attributes are accessed and modified using dot expressions. So if I've already created an account, I can look up its balance. I can also change its balance using an attribute assignment statement. The value of an existing attribute can be changed at any time. And now there's $12 in this bank account. An attribute can be assigned a value even if that attribute did not exist before. Let me give you a more complicated example. B is a separate account for a different account holder. It has a balance of 0. Here we set it to 20. Here, I'm creating an attribute called backup on the A account, which I created earlier, and assigning it the value of the B account, which I also created earlier. It's okay to have the value of an attribute be another object, such as an account. It doesn't have to be a number. And it's also okay to introduce a new attribute that wasn't named before. A new attribute can be added at any time in Python, and now we can refer to it. And here's an interesting expression. A.backup refers to B, and its balance is 20. So we have two different ways of referring to the same account, either B or A.backup. Let's talk about object identity. This is important because objects' attributes can change. So the objects can mutate, and so you have to know whether you happen to have two objects that are different with the same attributes or whether they are in fact the same object. Every object that is an instance of a user-defined class has a unique identity. So A account and B account are different accounts because I called account twice. Every call to account creates a new account instance. There's only one account class, but many instances. A has a balance and a holder. B has a balance and a holder. The identity operators is and is not test to see if two expressions evaluate to the same object. A is true because both of these are expressions that evaluate to the John account. A is not B because even though they have the same balance, and even if they had the same holder, they would be different accounts because we called account twice. Binding an object to a new name using assignment does not create a new object. If I say C equals A, it's still the case that C is A. They're just two different names for the same account.